Can you see my screen?
Not yet. Yes, now we can see.
Is it in presentation mode? No.
It is in. It is not yet in that presentation mode. Now it is.
Then
Yes.
it's lagging a bit. It's okay.
It's okay.
Okay. Good morning to everyone. Today I will be explaining about light emitting diode that we call LEDs. So the contents of the presentation are: first we'll begin with knowing what a diode is. We have actually already learned this. I'll just brief you about what a diode basically is, and then we'll see what are LEDs, and then about how the LED works, the advantages, the disadvantages, and then there are some points, important points from exam point of view, directly from the textbook, and then the applications of LEDs. So beginning with what is a diode. We have already covered, ma'am has already covered this in the previous lectures. A diode is a semiconductor device with two terminals, typically allowing the flow of current in just one direction. It does not allow the backflow of current. So that's also called as unidirectional current. PN junction, as you can see, this is the symbol of, one second. This is the symbol of the PN junction. So this is the most commonly used diode. There are many types of diodes, and here are a few. There's a signal diode, there's a power diode, there's a Zener diode, and then there is the light emitting diode, which we are going to talk about today. Any doubts are appreciated. You can stop me in the middle and you can just ask me. So this is a PN semiconductor, a PN junction, sorry. We will come back to this later. So what are LEDs? A light emitting diode is a semiconductor light source that emits light when current flows through it. Electrons in the semiconductor recombine with electron holes, releasing energy in the form of photons. So you know how a PN junction works, right? There's a P-type semiconductor, there's an N-type semiconductor, and then basically how LEDs work is when these holes and electrons they recombine in the band gap, that time they release either energy in the form of either photon or a radiation or as heat. So here in LEDs we use LEDs okay, releasing the energy in form of photons. The color of light corresponding to the energy of photons is determined by the energy required for electrons to cross the band. White light is obtained by using multiple semiconductors or a layer of light emitting phosphor on the semiconductor device. As I was talking about the working of the LED, the most important part is the semiconductor chip located in the center of the bulb. It is over here. So this is basically how LED looks, the diagram of LED. And this is the smallest part inside it. This is the semiconductor chip. There is the P-type semiconductor, N-type semiconductor forming a PN junction over here. And then there are positive and negative terminals that will be connected to the current. So as you can see, if I zoom in a bit, this is the PN junction. And this is what actually happens over here. In the area where there is the junction, the hole and the electrons, they recombine there. And when they recombine, as far as LEDs are concerned, there is a release of photon. So depending upon the band gap, right, you can decide what kind of photon you want. Like photons are not just visible light. No, we have IR photons, we have UV photons. So depending upon the band gap, we can decide what kind of LED you want. So continuing, the chip is basically a PN junction dominated by negative charges. A PN junction can convert absorbed light energy to proportional electric current and vice versa, which happens over here. So basically we are giving current and then we are getting out light. But how Shashank explained in the previous presentation that in solar cells, we take light and then we produce current. Here actually opposite is happening. Here we give current to produce light. So that phenomenon is also known as electroluminescence. The energy emitted on the recombination of holes and electrons dissipates energy in the form of heat and light. In case of silicon and germanium PN junction, we see there is a release of heat. But if you see gallium arsenide phosphide or gallium phosphide PN junction, there's a release of photons. So this is actually the material by which the semiconductor material by which our LEDs are made. So yes, I did not leave any point. This is the PN junction. Moving on, I explained the working of the LED. Advantages of LEDs. There is a low operational voltage and it needs less power. Why is this? We'll take an example of a filament bulb. it has a very high resistance. We provide it current so that it heats up. It heats up to such a temperature that it gives light. But what happens in LEDs is the release of photons is just the consequence of completion of a circuit. So just because the electrons are getting recombined with the holes, the light energy is produced. So you don't need much power or you don't need much voltage to produce light in this way. There is fast action and no warm-up time needed. So you must have seen these metal halide lamps, or also known as halogen lamps. It is used in stadiums, big stadiums. So what happens in these is it takes nearly 1 to 15 minutes to work on its maximum potential. But that doesn't happen in LEDs. As you can see, LEDs will just start immediately as soon as you give it its minimum voltage, what it is made for. As soon as you give that voltage to it, it will immediately light up. There is no warm-up time needed at all for LEDs. The bandwidth, I will come back to that point again, by the way. The bandwidth of emitted light is nearly 100 angstroms to 500 angstroms. That is, you can call it nearly monochromatic, not exactly. It has a long life and ruggedness. Just because its resistance is low and there is heat less produced, it's normal, and it's just understood that when there is less heat produced, the lifespan of any machine in general increases. And it has a fast on and off switching capability. That's again adding up to the same point. Disadvantages of LEDs. Initially, to make these semiconductor chips, it's kind of expensive. When you compare a tungsten filament bulb, if you compare LEDs, they are definitely expensive. Even if you go to a shop, you will get a CFL bulb for around 30 rupees. But for same thing, if you go to ask for LED, they'll tell you 250 rupees. So, but the same thing, if you, instead of buying 3 to 4 tungsten filament bulbs, you can just buy one LED bulb. That's a smarter choice because they have a higher lifespan and they last long basically, and they are temperature dependent. You know how semiconductors behave with temperature, right? As the temperature keeps on increases, the relative light output goes on decreases. This is a graph that will make you understand that. So that is one drawback of LEDs. And then this impact on insects. This is one thing that nobody talks about because they feel it is not a big deal. But actually, when you compare it to a metal halide lamp that I talked about and that we use in stadiums, LEDs are actually very harmful for insects. You know, the insects are so much attracted to LEDs that they are, in fact, some of the food webs are itself getting destroyed because of LEDs. It's the point of major concern, but it is not given the concern it actually needs. So that can be considered as one disadvantage. And then it is voltage sensitive. So the working voltage, what is given to it, like the rating which is given to it. For example, if it works between 1.2 volts to 2.9 volts, even if we give it 1 volt, right, the LED bulb won't start. But if you consider a filament bulb, if it's rated at 1 volt, even if I give it 0.2 volt, 0.4 volt, 0.5 volt, it will work at, the intensity of light will be less, but it will work. But that's not how LEDs work. LEDs need the exact rating. So if it's 1.1 volt, even if you put 1 volt or 0.9 volt, it won't work. And then if it's rated maximum voltage as 3 volts, if you give 3.1 volt or anything more than that, it will immediately spoil. It won't even take time. So that voltage sensitivity is very high in LEDs. That can be considered as one disadvantage. Some important points. This is directly from the textbook. It's important from exam point of view. You can get 1 mark questions. The semiconductor used for fabrication of visible LEDs must at least have a band gap of 1.8 electron volts. The band gap, the distance or the length is approximately 0.4 micrometer to 0.7 micrometer. This is for visible light that we use in our day-to-day life, not day-to-day life. Like if you see in circuits, we use it as a circuit indicator or something like that. So those lights which emit light in visible region, those need a band gap of 0.4 micrometer to 0.7 micrometer. The compound semiconductor used is gallium arsenide phosphide that I told you already earlier in making of LEDs. So what is this 1 to X and P of X? That is just for determining what color you want. That will just control the frequency of the photon emitted. Like I told, there are various types of LEDs. It's not just visible light what we see. There is UV LEDs. You must have seen these, what do you say? The fly. It's there in restaurants and all, you will see them, or some factories where food processing is taking place, we have these in many numbers. So what are these? These are UV LEDs placed inside a box kind of thing. So these attracts insects. So when insects are attracted to this, they get killed inside this. I don't know the exact name for this machine, but I'm pretty sure you know what it is. And then you have IR LEDs. IR LEDs work on the same principle. The photon emitted is a IR photon, and then it helps you to communicate with the receiver. So that is about LEDs. Moving on to applications. Applications are numerous, like innumerable, I can say. There are so many applications of LEDs, I cannot put it in a slide over here. There are just few examples here. Like you can see over here, there is the traffic lamp that we use. Those are basically made up of LEDs. And then the headlights of the cars. Most of them are made of LEDs only nowadays. We barely use anything else. We used to have halogen lamps on that also before. And then we have the Diwali lights that we use. Those are also LEDs itself. And then these big screens that you see in airports and in concerts and all, they are made up of tiny thousands of LEDs together. They make up these screens, even LED TVs, you know. So this is one metal halide lamp. I just wanted to show you how long the startup time is. It's like a small metal halide lamp. So if you compare it to a stadium lamp, this will start up faster, but stadium lamps take longer. So yeah, we can just watch this video. You can see it's still taking time to start. There's a warm-up time needed for those. It has to actually heat up to a particular temperature to be able to give out light. Still, it's not reached its maximum potential. Now it's glowing properly.
Is it your video? You did that?
No, mom. It's no, mom. I got it from YouTube.
Okay.
Yes, mom. Yeah, that is all about LEDs. Yeah, I've covered everything that is in the textbook plus a few other extra points. If you have any doubts, then you can ask me right now. Thank you.
Yes, students, any doubts?
No,
Tejas, Tejas,
No.
you did it very well.
Yes, mom. Thank you, mom.
Isn't it, students? His presentation, you have that convincing ability, Tejas.
Thank
All
you.
that positive energy you have to just channelize it properly. Sometimes you will behave like an odd person and get all the bad names. Right, Tejas? But any duty is given to you, you are doing it perfectly. That is a positive side. Very good, Tejas. The collection was good and
Thank
the
you.
presentation was also good. And it was like smooth. The way you presented it, it was smooth flowing without any hiccups. Very good. And informative.
Thank you, mom.
Yeah.
Yes.
Okay, students. This is where we are actually finishing our syllabus.